My dear students, welcome back to our channel. In this video, I will be explaining the Bcom 5th semester subject Business Economics as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is Production Function. The production function shows the relationship between inputs and output in the process of production. It explains how much output, goods or services, can be produced using a given amount of inputs like land, labor, capital, and raw materials. In simple words, it tells us how inputs are combined to produce output. It can be written as Q is equal to F L K, where Q is equal to output, L is equal to labor, K is equal to capital. Example: if a factory uses 5 workers and 2 machines to produce 100 shirts, and by increasing workers to 10, output becomes 200 shirts, this shows the production function. Easy to remember. Inputs go in, output comes out. The production function helps a producer decide how much to produce, what combination of inputs to use, and how to get the maximum output at minimum cost. In short, production function is equal to input-output relationship. Next important short question is average production. Average production, AP, means the output produced per unit of input. It shows how efficiently each unit of a factor, like labor or capital, is used in production. In simple words, average production tells us how much each worker or machine produces on average. It is calculated as AP is equal to total product, TP, number of units of input, L. Example: if a factory uses 5 workers to produce 100 toys, then AP is equal to 105 is equal to 20. So, each worker produces 20 toys on average. Easy to remember. Average production is equal to output per worker. As more workers are added, AP first increases due to teamwork and efficiency, then decreases when too many workers crowd the workspace. In short, average production shows the efficiency of each input, helping producers decide the best number of workers or machines to use for maximum productivity. Next important short question is returns to scale. Returns to scale explain how the output changes when all inputs, like labor, land, and capital, are increased in the same proportion in the long run. In simple words, it tells us what happens to production when the size of the business grows. There are 3 types of returns to scale. Increasing returns to scale. Output increases more than proportionately. Example: doubling inputs doubles more than double output. Example: 2 times input 3 times output. Constant returns to scale. Output increases in the same proportion as inputs. Example: 2 times input 2 times output. Decreasing returns to scale. Output increases less than proportionately. Example: 2 times input 1.5 times output. Easy to remember. Increase more, constant same, decrease less. In short, returns to scale show the long-run relationship between input size and total output, helping firms decide how big they should grow for maximum efficiency. Next important short question is 4 isoquant. An isoquant is a curve that shows different combinations of 2 inputs, like labor and capital, that produce the same level of output. In simple words, an isoquant means equal quantity. It tells us how a producer can replace one input with another without changing total production. It is similar to an indifference curve, but instead of satisfaction, it shows output levels. Example: a factory can make 100 chairs using combination A, 5 workers plus 3 machines. Combination B, 3 workers plus 5 machines. Both combinations produce the same 100 chairs, so they lie on the same isoquant. Easy to remember. Isoquant is equal to equal output curve. Properties of isoquant: slopes downward from left to right. Convex to origin due to diminishing marginal rate of substitution. Higher isoquant is equal to higher output. In short, isoquant helps producers find the best combination of labor and capital to produce a given level of output efficiently. Next important short question is 5 ISO cost. An ISO cost line shows all possible combinations of two inputs, like labor and capital, that can be purchased with a given budget at current prices. In simple words, it means equal cost line. It tells us how much labor and capital a producer can buy spending the same total money. It is similar to a budget line in consumer theory. The formula is C is equal to PL times L plus PK times K, where C is equal to total cost, budget. P is equal to price of labor. L is equal to units of labor. P is equal to price of capital. K is equal to units of capital. Example: if a firm has 1000 rupees, wages per worker is equal to 100 rupees and cost of a machine is equal to 200 rupees, then possible combinations, like 10 workers plus 0 machines or 5 workers plus 2.5 machines, lie on the same ISO cost line. Easy to remember. ISO cost is equal to equal money curve. In short, ISO cost helps a producer decide the best mix of labor and capital that fits their budget to minimize cost and maximize output. Next unit 4. Long questions. First important long question is: explain the law of variable proportions with an illustration and diagram. Law of variable proportions with illustration and diagram. Meaning: the law of variable proportions explains how output changes when one factor of production, like labor, is varied while other factors, like land or capital, are kept constant. In simple words, it tells us what happens to total production when we add more workers or inputs to a fixed resource, like land or machine. This law applies only in the short run, where some inputs are fixed and others are variable. Statement of the law: as more units of a variable factor are combined with fixed factors, total production first increases at an increasing rate, then at a decreasing rate, and finally starts to fall. Example: suppose a farmer has 1 acre of land fixed and adds laborers one by one. Know of workers' total product, TP, marginal product, MP. 110-10, 225-15, 335-10, 438-3, 535-3. When workers increase from 1 to 3, TP increases rapidly, increasing returns. After 3 workers, TP rises slowly, diminishing returns. After 4 workers, TP falls, negative returns. 3 stages of the law. 1. Stage I, increasing returns. Each additional worker adds more output due to better use of fixed resources and teamwork. 2. Stage 2, diminishing returns. Output still rises, but slowly. Best stage for production, most efficient. 3. Stage 3, negative returns. Too many workers cause overcrowding and confusion. Total output falls. Diagram to draw in exams. X-axis units of labor, variable factor. Y-axis output. Curve of TP first rises steeply, then slowly, then falls. Easy to remember trick. Rise fast, rise slow, fall down. In short, the law of variable proportions shows how changing one input affects output, helping producers find the most efficient level of production. Next important long question is to explain the law of returns to scale with an illustration and diagram. Law of returns to scale with illustration and diagram. Meaning, the law of returns to scale explains how output changes when all inputs, like land, labor, and capital, are increased in the same proportion in the long run. In simple words, it tells us what happens to production when a business expands its size by increasing all factors together. Statement of the law. When all inputs are increased in the same proportion, output may increase in a greater, equal, or smaller proportion. These are called increasing, constant, and decreasing returns to scale. Types of returns to scale. 1. Increasing returns to scale. Output increases more than proportionately to the increase in inputs. Example, if all inputs are doubled, output becomes more than double. Example, 2 times input, 3 times output. Happens due to better management, specialization, and use of modern machines. 2. Constant returns to scale. Output increases in the same proportion as inputs. Example, 2 times input, 2 times output. Firm operates at optimal size, maximum efficiency. 3. Decreasing returns to scale. Output increases less than proportionately to input increase. Example, 2 times input, 1.5 times output. Caused by poor management, lack of coordination, or overexpansion. Illustration. Scale of inputs, total output, type of return. 1 unit 100. 2 units 250 increasing. 3 units 300 constant. 4 units 320 decreasing. Diagram to draw in exams. X-axis, scale of inputs. Y-axis, total output. Curve rises steeply, increasing, then straight, constant, and finally flattens, decreasing. Easy to remember trick. Grow big, grow sane, grow less. In short, the law of returns to scale shows how output reacts when all inputs increase together, helping firms decide the best scale of production for maximum efficiency. Next important long question is 3. Explain the producer's equilibrium with the help of isocost and isoquants. Producer's equilibrium with the help of isocost and isoquants. Meaning, producer's equilibrium means the situation where a producer achieves maximum output or profit with a given cost, or produces a given output at the lowest cost. It is determined with the help of isoquants, equal output curves, and isocost lines, equal cost lines. In simple words, a producer is in equilibrium when he gets the best combination of labor and capital that gives maximum production for the minimum cost. Concept of isoquant and isocost. Isoquant shows different combinations of labor and capital giving the same output. Isocost line shows different combinations of labor and capital that can be bought with a given budget. Conditions for producer's equilibrium. Isoquant is tangent to isocost line. The producer's equilibrium is at the tangency point where both touch each other. Here, slope of isoquant is equal to slope of isocost. Mathematically, Mrs. LK is equal to PL/PK, where Mrs. is equal to marginal rate of technical substitution, and PT is equal to price ratio of labor and capital. Isoquant must be convex to origin. Ensures diminishing misses and stable equilibrium. Example. A furniture factory uses labor, L, and machines, K. One combination, 5 workers plus 3 machines, 100 tables. Another, 3 workers plus 5 machines, 100 tables. Both lie on the same isoquant. When the firm's budget line, isocost, just touches this isoquant, the firm achieves producer's equilibrium, producing 100 tables at minimum cost. Diagram for exams. X-axis labor, L. Y-axis capital, K. Tangency point between isoquant, IQ, and isocost line, IC, shows equilibrium. Easy to remember trick. Touch point is equal to best point maximum output, minimum cost. In short, a producer's equilibrium occurs when the isoquant is tangent to the isocost, meaning the firm uses the most efficient combination of inputs to achieve maximum output with least cost. Next important long question is: 4. What are the internal and external economics of large-scale production? Internal and external economies of large-scale production. Meaning of economies of scale. When a firm produces goods on a large scale, the cost per unit decreases because production becomes more efficient. These cost advantages are called economies of scale. They are of two types, internal economies and external economies. 1. Internal economies. Internal economies are the cost advantages that arise within the firm when it expands production. In simple words, as a firm grows bigger, it can produce more at a lower average cost. Types of internal economies. 1. Technical economies. Use of advanced machines increases efficiency. For example, a car factory using robots to speed up production. 2. Managerial economies. Skilled managers improve planning and reduce waste. 3. Purchasing economies. Large firms buy raw materials in bulk at cheaper rates. 4. Marketing economies. Large-scale advertising reduces per unit marketing cost. 5. Financial economies. Big firms can borrow money easily at low interest rates. Result: internal economies help a firm reduce costs and increase profits. 2. External economies. External economies occur outside the firm but within the industry. They arise when the whole industry expands and all firms benefit. In simple words, growth of the entire industry helps every firm reduce cost. Examples: 1. Improved infrastructure, better roads, power supply, or transport help all firms. 2. Development of skilled labor. Training institutes create skilled workers for the industry. 3. Specialized suppliers. More suppliers provide cheaper and better raw materials. 4. Research and innovation. Industry research benefits all producers. Result: external economies make the whole industry more efficient and competitive. Easy to remember trick. Internal is equal to inside firm benefits. External is equal to outside industry benefits. In short, internal economies lower cost due to firms' own expansion, while external economies lower cost due to growth of the entire industry, both leading to cheaper and more efficient large-scale production. Next important long question is: 5. Explain the economies and diseconomies of scale. Economies and diseconomies of scale. Meaning, when a firm increases production, the cost per unit may fall or rise depending on efficiency. Economies of scale, cost per unit decreases as production increases. Diseconomies of scale, cost per unit increases when production increases too much. 1. Economies of scale. These are advantages of large-scale production that help reduce average cost. Types and examples. 1. Technical economies. Better machines and technology increase output per unit. Example, using robotic assembly lines in a car factory. 2. Managerial economies. Specialized managers improve efficiency. 3. Financial economies. Big firms get loans at lower interest rates. 4. Marketing economies. Advertising cost per product reduces when selling more. 5. Purchasing economies. Buying raw materials in bulk at cheaper prices. Effect: as the firm grows, production becomes cheaper and more efficient. 2. Diseconomies of scale. When a firm becomes too large, costs may rise instead of falling. Reasons and examples. 1. Coordination problems. Difficult to manage a very large workforce efficiently. 2. Communication problems. Information may get delayed or distorted. 3. Employee demotivation. Workers may feel less responsible in very large firms. 4. Overcrowding of resources. Too many machines or people may reduce efficiency. Effect: the average cost increases, making production less efficient. Diagram for exams. X-axis output. Y-axis average cost. Curve falls initially, economies of scale, reaches minimum, optimum scale, then rises, diseconomies of scale. Easy to remember trick. Grow right cheaper, economies, grow to big cost rises, diseconomies, dot. In short, economies of scale help a firm reduce costs and become more competitive. Diseconomies of scale occur if a firm grows too large, causing inefficiency. Optimal production happens where average cost is minimum, balancing economies and diseconomies.